Okay, one last example here. This time let's solve a rotten looking rational inequality. We've got 2 over x plus 1 is greater than or equal to 2. The very first step is that whenever you've got a rational inequality or a quadratic inequality, you set it to 0. So that means that we're going to have to rewrite this a little bit. We're going to have 2 over x plus 1 minus 2 greater than or equal to 0. Now, before we can find any linear factors, we're going to have to simplify this. So we're going to have to actually rewrite this fraction as a single rational expression. So that means we're going to have to combine 2 over x plus 1 minus 2 over 1. And that means that we're going to have to combine using a common denominator right here of x plus 1. So I'm going to multiply by x plus 1 everywhere. When I do that, I get 2 minus 2 times the quantity x plus 1 in the numerator divided by x plus 1. So when I combine those together, remember this is all still greater than or equal to 0, I'm going to get 2 minus 2x minus 2 divided by x plus 1, still greater than or equal to 0, and this turns into negative 2x divided by x plus 1 greater than or equal to 0. All right, so what we're going to have to do is this is the expression that we're going to have to test when we find all of our linear factors. Well, we do have our 2 linear factors right here. Our linear factors are 2x and x plus 1. So where are the zeros? The zeros occur at x equals 0 from the numerator, right? If 2x is equal to 0, then x equals 0. And x equals negative 1 from the denominator. So that's what we're going to mark on our number line. We're going to get those numbers 0 and negative 1. But let's mark a few numbers around it so we know where we're at relative to those values. Here's negative 2 over here. Here's negative 3. So we mark the zeros on the number line, so let's go ahead and mark them right here in blue. X equals negative 1 and x equals 0. And what we're going to do is we're going to determine the intervals over that number line. So we want to determine our intervals. In this case, we've got 3 possible intervals. One from negative infinity to negative 1. One from negative 1 to 0. And one from 0 to positive infinity. And so these are the ones that we're going to test. And so we're going to have to choose some test values within each interval. Well, let's try x equals negative 2. I'm going to test this guy right here. Now I could actually test right here and see if that makes it true. Well, let's try it here. This looks pretty simple. If I put 2 divided by negative 2 plus 1, do I get a number that's greater than or equal to 2? Well, the answer is no, because 2 divided by negative 1 is not greater than or equal to negative 2, or greater than or equal to 2. So this is not part of our solution interval. But we definitely need to get a number somewhere between 0 and 1, negative 1 and 0. So let's choose one here at negative 1/2 and test it. So I'm going to use my original interval right here, or expression 2 over x plus 1 greater than or equal to 2. So I'd have 2 over negative 1/2 plus 1. And I want to find out if that's greater than or equal to 2. Negative 1/2 plus 1 is positive 1/2. So I've got 2 divided by positive 1/2, and I want to see if that's greater than or equal to 2. 2 divided by 1/2 is the same thing as 2 over 1 divided by 1 over 2. That's 2 over 1 times 2 over 1. And yeah, that is greater than or equal to 2 because 2 divided by 1/2 is 4. And 4 is greater than 2, so this is part of our solution set, so we would fill in this piece of the number line as part of our solution set. Okay. Then we check our last interval right here. Let's just check it with x equals 1 to see what happens. If I take 2 and I divide it by 1 plus 1, do I get a number greater than or equal to 2? The answer is no. 2 divided by 2 is not greater than or equal to 2. So, this is not part of our solution interval. So, in our interval notation, we'll write out our solution as the set from negative 1 to 0, including the endpoints, or in set builder notation, the set of all values of x such that x is between negative 1 to 0, including possibly 1 and 0. That's our solution set, so we're done. That's what we were looking for. Good luck on your homework.